This demo showcases Amber, an SoC with a coarse-grained reconfigurable array for flexible acceleration of dense linear algebra applications, which include image processing, computer vision, and machine learning. The Amber coarse-grained reconfigurable array, or CGRA, is for application acceleration and contains 384 processing elements, which support N16 and bfloat16 operations and 128 memory elements. The global buffer sits on top of the CGRA and streams data and bit streams to the CGRA. The whole Amber SoC consists of an accelerator subsystem and a processor subsystem. The accelerator subsystem is the global buffer and CGRA. The processor subsystem manages application execution and contains an ARM M3 Cortex CPU. The key contributions of Amber include fast dynamic partial reconfiguration that allows us to run up to 8 kernels in parallel, efficient streaming memory controllers to support affine access patterns, which we see commonly in dense linear algebra applications, and low overhead complex arithmetic support in our processing elements to support operations such as logarithm, division, sine, and exponential. We've designed an end-to-end compiler flow to map halide applications, a language embedded in C++, onto our CGRA. So given our halide application, through our toolchain, we will first run through a polyhedral scheduler, which will transform the halide program into a graph of operations. Our mapper will then take that graph of operations and transform it into our processing elements and memory elements. The placer and router will then take that graph of elements and place it actually onto the tiles on the CGRA, and then eventually we'll generate the bit stream to run the program on the CGRA.
Hi everyone, this is the Amber chip measurement setup. On the right here, we have the computer and monitor which run applications on the chip. Here we have the board, which houses the Amber chip, and over here we have a power supply module, which we use to measure current so that we can calculate power and energy for our chip. In my right hand, we have the chip. This chip is housed in this socket here and can be powered either through the external power supply, which we showed before, or using a 12-volt source, which is broken down into 2 voltages controlled by these 2 power supply modules. We are able to program these power supply modules with the Raspberry Pi here. In addition to being able to program the power supply modules, we can also program the clock that reaches the chip with this clock generator here. This allows us to run applications at different frequencies. Finally, we have the FPGA, which conducts applications running on the Amber SoC, and we have JTAG, which allows us to debug the chip. Now I will demo 2 applications that run on the Amber chip. The first application is the unsharp application, which is an image sharpening technique. The unsharp application works by enhancing local contrast by isolating the high-frequency content of an image and combining it with the original image. In this unsharp application, we take as input a parrot. Once we run the application, we'll see that the output of the unsharp application is a parrot with sharper details. So here on the left, we have the input to the unsharp application, and on the right, we have the output of the unsharp application. The next application we run is the camera pipeline application. The camera pipeline application processes raw images into an RGB image using hot pixel suppression, demosaicing, color correction, gamma correction, and contrast enhancement. The input to the camera pipeline application is a Bayer image. The Bayer image is the output of the camera sensor. The Bayer image consists of RGB pixels in a grid-like fashion, shown here. Once we run the camera pipeline application, we get the output, which is an RGB image of the original input. So on the left, we have the Bayer image, and on the right, we have the RGB image of a dog. Now let's look at the results for these 2 applications. Here you can see that compared to a CPU, GPU, and FPGA, the unsharp application has up to 864 times better EDP. Similarly, for camera pipeline, we show up to 3,902 times better EDP compared against those hardwares. In conclusion, in this demo, we show two of the many applications we can accelerate on the Amber SoC.